Hello PLP Geometry, welcome to the 5th lesson of Unit 5. So we are now transitioning from our congruence transformations into our congruent triangles. So this is our transition lesson video for that. So again, Unit 2 we are still in. So congruence transformations with our triangle. Okay, so again, this is video number 5, and we are talking about congruent figures. And again, more specifically, I'm focused on triangles, right? So you're going to work with congruent figures today. You're going to see some quadrilaterals, some pentagons, but again, in the future, it's going to be focused on triangles. So we talked about like what congruent segments were in Unit 1 and what congruent angles were in Unit 1, right? So now we're going to put those ideas together and make figures, okay? So what does it mean to be a congruent figure? All right, well, let's write down a definition. So congruent figures. Going to be plural because there should be 2 of them, right? So for 2 figures to be congruent, these figures, so congruent figures are figures that have the same size, and same shape. And I feel like we've talked about this before in the first video, right? When we talked about what rigid motions were, right? And how they kept figures congruent. So now we're kind of doing a full circle thing, right? We did all those congruence transformations and those rigid motions, and now we're going to focus on congruent figures. Now you're still going to see some transformations today, but this is the last day with these transformations. Okay, so again, to add to this definition, and I'll keep the same color, right? Figures are congruent if there is a rigid motion. And in parentheses, I'm going to put congruence transformation. Because again, remember, rigid motions are congruence transformations because they preserve size or length and angle measure. So if there is a rigid motion or a congruence transformation that maps one figure onto the other. Figures are congruent if there is a rigid motion or a congruence transformation, right? And I'll put an underline under there because that's a vocab word from before, or a congruence transformation that maps one figure onto the other. Now, this could be one single rigid motion, or it could be a combination. You're going to see in today's practice that there can be combinations. And again, I think you'll be able to handle it, and I'll walk you through one of them. All right, so let's just draw a little picture. So again, if I have a triangle, all right, I'm going to call this triangle ABC. So A, B, C. And over here, I have a almost exactly the same triangle. Try your best. I know we're just humans. We can't just... And I'm going to call this D, E, F. So the idea behind this lesson is there a rigid motion we can use that would take triangle ABC and map it right on top of triangle DEF? And the answer is yes, right? If I were to take a vertical line and draw it, so if you want to be technical, right? If I connect A and D, which are the corresponding vertices, find the segment that connects them. Find the midpoint of that segment and then draw that vertical line, again perpendicular, right? I did this on purpose, horizontal versus perpendicular, straight down. This would be the line of reflection, call it L. And if you were to reflect ABC across L, A would line up at D, B would line up at E, B prime, C would reflect over to F, C prime. And if I were to reflect the entire triangle, it would map on top of triangle DEF. So we say there exists a line of reflection or a reflection in general that maps triangle ABC onto triangle DEF. Therefore, triangle ABC would be congruent to triangle DEF. Okay, so let's talk about what happens if the figures are congruent. Okay, there is this phrase called corresponding parts of congruent, and we're going to focus on triangles. We could call it congruent figures, but the phrase we're going to use in the future is congruent triangles. Corresponding parts of congruent triangles are congruent. This phrase has an acronym. It is just the first letters of each word in the phrase. So the acronym is CPCTC. We will use this a lot in the future with our triangle proofs. So I'm going to draw those same two triangles we just had on the last page. So I'm not going to put the line of reflection though. So I'm going to put triangle ABC here again. So this was A. And then we're going to draw a triangle DEF. And what's going to happen here is we are going to identify the corresponding parts of these two triangles, and we're going to say that they're congruent, because in this phrase, corresponding parts of congruent triangles are congruent. So we talked a little bit about correspondence when it came to parallel lines, and if you remember, I mentioned that the corresponding angles are in the same position. Well, the same thing here. We're looking for the corresponding parts that are in the same position. Okay, so again, down here. So we know, because there's a reflection that exists that maps ABC onto DEF, we know that triangle ABC is congruent to triangle DEF. We know this. So then we know that the corresponding sides are going to be congruent. So I'm going to put the word sides here, and in parentheses I'm going to put the word size, because it is the sides and their lengths that control the size of these figures. Okay, so if I look at side, and I'm going to use segments, side or segment AB. Segment AB corresponds to segment DE in the other triangle. They're going to be congruent. Notice they use the tick marks, one on each side. Notice in the naming, AB comes first, DE comes first. So when you name the figures, they have to also be in corresponding order. All right, side BC is going to be congruent to, so BC will be congruent to EF. And segment AC, you could also call it CA, this top one, I'll put 3 tick marks, will be congruent to segment DF. And there are the list of the corresponding sides that are congruent between these two triangles. We will do the same thing with the angle. So over here I'll put the word angles. And again, angles control the shape of your triangle. So because these two triangles have the same shape and angle measure is preserved, right, that's why they're congruent. So angles. So we're going to use one letter. So angle A is congruent to. I'll put one arc mark on A. Angle A is going to be congruent to angle D. I'll put one arc mark on D. Again, A and D are the first letter in the triangles. So they're going to be corresponding and congruent. We'll do the same thing with angle B. So I'll put 2 arcs down here and angle E. And the same thing with angle C and angle F. I'll put 3 there and 3 there. So this is what we mean by corresponding parts of congruent triangles are congruent. So in the problems, you'll see it's going to ask you what angle or side or even sometimes what point corresponds to a point. You got to tell them. All right, so I do want to do one practice problem with you. I have it loaded up. So let's get to that point right now. It is here. Okay, so this problem says, use the drop-down menus below to state the sequence of transformation that maps figure T onto figure U in the animation below. Then use transformations that determine are the two figures congruent. Use the drop-down menus to explain why or why not. Okay, so hint, they're going to be congruent. So I'm going to give you that piece. So the first job is, can you identify the two transformations used to make figure T map onto figure U? So blue. So notice the first thing they're doing. They're taking blue and they're rotating it. Notice it's going 1, 2 quadrants. So this is a 180 rotation. So first, we're doing a rotation of 180 degrees. Now, which way is it going? It's going against the clock, right? It's going against the clock. That is counterclockwise. Okay. Then, what are we doing next? Well, from here, it is sliding up. When you slide, that is called a translation. Now, it's going to ask you what direction. So I'm sliding up, and by how many? Well, I just count to see how long it takes or how many squares it takes to get the corresponding vertices on top of each other. So if I go here, I go 1, 2, 3, 4. 4 units up. So these two figures will be congruent. So they are congruent because a rotation and a translation are rigid motions. And we are done. Okay, I want to do one more problem with you. Okay, here's the second problem. So it's determine if the two figures below are congruent. Newsflash, they're going to be congruent. Okay, so they're going to be congruent. Use the drop-down menus below to justify why. Which angle on figure 2 corresponds to angle K on figure 1? Okay, so if you take a look here, right, they're going to want you to kind of think about how these things line up. Okay, so again, they're not going to make you, I don't think, ask. They are going to be congruent, so are congruent. And again, they're just going to have you say because of rigid motions, right? If I was looking at this, I think I know I have to rotate this figure. Or maybe actually I think I could reflect this figure, right? Because R and K line up, right? Reflect this figure and then move it with a translation. So now they want to know what angle corresponds to angle K. So this might be tough for you to see. So I am going to take a picture of this and draw on it. So give me 1 second. Okay, so here's my figure that I can draw on. So they want us to figure out what angle is going to be corresponding to angle K. So again, what I said is I think I would reflect it up. So again, I'm gonna do this with you. You don't have to actually do this when you do the problem, as long as you can see what corresponds. If I reflect this over the x-axis, so K is going to go up 1, 2, 3, 4, 5. So 1, 2, 3, 4, 5. So here's K. I'll call it K prime. H would be the same thing straight up. J, 1, 2, 3, 4, 5, 6, 7, 8. So 1, 2, 3, 4, 5, 6, 7, 8. There's, I'm sorry, that's I prime. J would be 9 up. And there's the figure, right? So here would be the reflected figure. And then if I slid this triangle to the left, and we would go, let's go K prime, would go 1, 2, 3, 4, 5, 6. So we'd go to the left 6 units. That would mean that K would land on R. And that means that angle R, let me erase that circle I just did, that angle R's angle would be congruent to angle K's angle. So back on the problem, I would come down here and I would say, okay, the angle that corresponds to angle K is angle R. There we go. All right, best of luck with this assignment. Thanks for watching the video. I'll be there to help you.